let's dive into topic. Primarily, there are two major steps while doing the pre-engineered building or any kind of structural system or engineering project. Primarily, we have to do an estimation for the project. So initially, an inquiry comes from the client that they wanted to build and they have to have some warehouse shed or engineering shed. So there may be some certain tonnage consumption, certain design methodology to be followed. So based upon that, we cannot say initially that this building should be of somewhat uh, so and so cost that we have to design initially. So that procedure comes under the estimation department. So initially we estimate the structure, and while estimating the structure, we have to decide a material specification, and we have to decide a project valuation. Okay, and those material specification, project valuation goes to the client along with the proposal drawing. So sometime we do proposal drawing in a 3D manner, also in a 2D manner also, so that the client gets a clear idea about the manufacturing, and about the material, and about the principal geometries of the structure, that till up to when we are using the walls. Sometimes we use walls in a PB structure up to 3 meter height, so that the entrance and the windows can accommodate easily. Then we use a sheeting over there. Then many different type of hardwares, and many different type of systems which we are going to use in a PB structure, so that can be easily visible in the 3D proposal steels warehouse details. So once we finish the estimation part, we do a structural designing. In that structural designing part, we estimate, we evaluate the load, upcoming load, like dead load, live load, collateral loads. Sometimes a shed may have collateral loads like solar panel loads. Okay, and then dead loads and live loads shall be applied as per the assigned codes. And then wind load, which is majorly a governing load for the pre-engineered buildings. So when the shed when the load evaluation shall be completed, then we go for the detailing. Okay, after the load evaluation, one more step is there, which is a connection design. So in steel structure, we can say half of the design part will taken care about the material, the member design, and then half of the design can be done with a connection design, because connection design is the most important aspect in the in the steel engineering industry. Okay, so we do connection designs also majorly in pre-engineered buildings. End plate connections are used, which we will see in further slides. So this is one of our project which we have done for the BPCL, which is 35-meter clear span. It is bottling plant for the BPCL. And you can see a live image also of the project. So we did the Tekla modeling for the same. Once the design has been completed, then we proceed further for the Tekla modeling, then which is a 3D modeling system. Then after the Tekla modeling, we can go easily for the shop drawings and manufacturing production drawings. So these are all our projects which we have done on Tekla. So the connections and members can be easily modeled, and then we can see if some clashes can happen, may happen with the piping and the secondary elements of the project. Okay, so initially we do designing softwares may be used. We can use STAD Pro, or other softwares also can be used, like ETABS also can be applicable. But majorly in our industry, people are using a STAD Pro for the steel engineering design, and for RCC people are using ETABS. Okay. So if we proceed ahead, after the designing part, we do connection design as I described. Then we proceed for the modeling in Tekla. Then after that we proceed for the drawings. Okay. So this is what the plinth beam drawing, foundation placement drawing. Okay. Where we have to show the foundation, the bolts which are going to be placed in a pedestals. Okay. These are the steps. So these are some live photos of our previous projects where we have placed bolts, anchor bolts plays a very important role, in steel engineering industry, steel construction industry. Anchor bolts have to design for the governing moments and governing pull out and uplift forces, majorly a wind uplift, for the wind uplift. And anchor bolts are designed for tension forces. Okay. uh, Tension forces are the major forces which comes on anchor bolts. Okay. So plates and bolts are designed on some softwares like Idea Statica, and manual spreadsheets are also been followed for the same. Okay. So this is what some images of anchor bolts. Anchor bolts shall have to place initially while concreting, so that it will fix, in a pedestal. Okay. So these are of some live images of anchor bolt placements. Okay. So there are two types of, we can say, anchor bolts systems: pinned system and fixed systems. Because we design structure as a pinned base or a fixed base. Okay. So for a pinned base, the anchor bolts are within your web limit. Okay. There may not be extended plates. And for a fixed base, there will be an extended plates, large size plates, where plate can be, stiffened enough to take the uplift moments, applicable moments, and upcoming moments, we can say. And in pin base, it is only designed for the normal tension, we can say. Okay. So here we are describing the elements of pre-engineered building. Uh, the frame, which is in red, which is called main frame section. The connections are end plate connections. Okay. It is secondary element which is called purlins. The secondary elements are majorly in cold form sections, because pre-engineered building is having its own, elemental family, which we can say, which suits the joineries properly, which is, properly, which makes a proper homogeneity among each elements. And it is totally depends on the design and drawing. Okay. So if there is an error in drawing, if there is an error in modeling, so there must be an error in a erection in on site. There must be an error. If your drawing and design is properly as per the site, there is a proper dimensional matching, in design and modeling, so that it suits the site conditions and it fit on site. Otherwise, it gives you an error and you will have to go for a site remedial measures. Okay. So here we are showing a mainframe structure, then secondary purlins, and segrods, which is a tertiary member, we can say, which ties the purlin, so that purlin, the secondary buckling and the local buckling can be, eliminated in purlins, because purlins are very thin members. It's around 1.5 meter, 1.5 to 2.5 member sizes. And it depends upon the coil sizes, like you have a coil size of 1200 or 1000 or 900 and based upon that coil size, we divide that coil size and it place it into a manufacturing machine, and that manufacturing machine rolled it in Z type shape or C type shape. Okay. One more advantage, you cannot have to take your welding machine to site. Everything is bolted every element is bolted, and the erection procedure, if you take a welding machine to site, there are certain issues may happen, certain disadvantages may be there, like there may be a loss of strength also, because while designing we reduce the strength if we weld on site, and we increase the strength if we weld on factory. So you cannot have to take your welding machine to site, because everything is bolted, and every assembly has planned in such a manner that you have to design, you have to place, you have to bolt every assembly properly on site by its numbers. So this is what the end wall arrangement. In on end wall frame, you have to provide the column in certain intervals, because there will be a sheeting on end wall. Okay, so there are some details, and certain assemblies are there, certain hardwares are there, certain sheeting assemblies are there, which is going to place after the placement of sheets are also designed and planned accordingly, and sheeting working drawings for sheeting also have been drawn by engineering design team. And once we finish the sheeting drawing, we pass it on for the sheet manufacturing company, and then they manufacture those sheets according to our sizes. In local market we got a size of 10 feet, 12 feet, 16 feet sizes, uh, which is molded, and which is cutted pre-handedly. But in our case, in pre-engineered building case, we model and we design the sheets, we give the drawing of sheets according to our site conditions. If your site needs 8-meter sheet length, we can give 8-meter sheet length. By keeping in mind the transportation, we can provide sheeting length accordingly. Okay. Okay, so in shop drawing, the every elements is clearly mentioned along with its weights. Okay, and every elements, every weld, every connection, every bolt punches, every dimensions uh, in x and y directions, and every assembly, everything is mentioned here in shop drawings. So according to shop drawings, fabricators fabricate everything, create an assembly properly in a factory, and then that assembly transport to the site along with along with its fabrication name. Like this particular assembly may have certain names. If you see here, we have mentioned which is C1. Okay, so while erecting the columns, the C1 number is mentioned on a plan, and this the C1 also punches on this particular column, so they will erect the C1 at its particular location. This is a welding machines which we use for pre-engineered building. Very less we can say uh, very negligible time we use arc welding machine, because it is a big welding task. So arc welding machine is used for local fabrication work. We use SAW definitely. Nowadays, for a huge factories, people are using automatic welding machines, which is computerized welding machines. But in a medium range factories, people are still using the SAW machine like this. Okay, so the upper panel, like which is flanges and web, both been cutted with the uh, plasma cutting machine or shear machine, and then place it on a rack. Okay, where we can weld it on a with a SAW machine, or different type of welding systems. Okay, so alternate weldings are there. On one side we do this SAW welds, and the other side there is a tech weld. Okay, so after welding, it goes to painting, where we can do a sandblasting or primer application, for on a ready available sections which we build according to the design. This is a purlin machine. Okay, where we bend the purlin it is cold form. The name it shows you, a cold roll is placed in a machine, and according to your sizing, according to your hole punching, it gives you a slotted holes here, you can say, which is slightly adjustable on site. Okay. And this depth may be vary around 200 to 250 Okay. Then finally, a day where the day comes where you do an erection for a pre-engineered building. So every assembly lifts properly by means of hydra and by means of rana, and different type of machineries use for the erection, for the man movement on a site. And accordingly, the pre-engineered building erected on site, properly and a decently manner. Here you can say all the safety aspect also have been taken care here, on site. The belts and safety helmets also, you know used for proper erection of the site. These are some live images of canopies also been provided. Okay. This is the sliding door. Thank you, thanks a lot.